All right, here we are, quarter four, week four, day 3. We have a multiplication problem and we have a division problem with decimals. So each one of them has their own thing that we have to do with it. So we'll have 83.49 times 1.48. It turns out that the decimals are lined up, but we don't really have to worry about that with multiplication. All right, let's go ahead and start solving this. 9 times 8 is 72, so we'll put the 2 there, a 7 up here. 8 times 4 is 32. 32 plus 7 is 39, so we'll put the 3 up here, the 9 down here. 8 times 3 is 24, plus 3 more is 27. 8 times 8 is 64, plus 2 more is 66. Okay, so now we'll just go ahead and put the little spacer here, and now we'll move on to the 4. Let me do a different color just so we can make sure we're not crumping into each other. 9 times 4 is 36, so we'll get a 3 up here, put the 6 here. 4 times 4 is 16, plus 3 is 19. Put the 9 down here. 4 times 3 is 12, plus 1 more is 13. And then 4 times 8 is 32, plus 1 more is 33. Okay, and then the last one is the number 1. Okay, so that's going to be pretty easy. We're just going to put space, space. And then 1 times 9 is 9. 1 times 4 is 4. 1 times 3 is 3. And 1 times 8 is 8. Okay, so now let's add these up. So we have 2 and nothing is just 2. We have 9 plus 6, which is 15. Carry the 1. We have a 9 and a 9, and then basically an 8, right? So 9 and 9 is 18. So 18 plus 8 is equal to 26. Carry the 2. All right, so 4, 5, 6, 7. All right, so we have a 6 and a 7, which is 13, 14, 15. Carry the 1. We have 3 and 3, which is 6, plus another 6 is 12, plus 1 more is 13. And then we have 8 plus 3 plus 1. So 8 plus 4 is 12, right? Is 12. And then we'll look at how many places do we have to move the decimal? 1, 2, 3, 4 places. 1, 2, 3, 4. So it should be 123.5652. 123.5652 is the answer to that multiplication problem. All right, so now we have the division problem, which means we have to get rid of these decimals, right? So we moved them over one place, and I rewrote it so that the divisor does not have a decimal in it, right? So we don't want that. So how many times does 28 go into 4? It cannot. How many times does 28 go into 43? Well, just one time. So it's going to be 1 times 28, which is 28. So then we have 43 minus 28, and that gives us 15. So we have 15 down here. We're going to bring down this 7. All right, so how many times did 28 go on into 157? Well, 28 is close to 25, so no, I know 4 25s gets us to 100, and then 2 more 25s gets us to 150. So probably let's try 6, because I think that's going to be pretty close. Okay, so 6 times 8 is 48, and then 6 times 2 is 12, plus 4 more, 16. So 6 won't work, will it? It's just going to go a little bit too high. So let's get rid of the 6, and let's make it a 5. All right, so it's going to be 5. 5 times 8 is 40. 5 times 2 is 10, plus 4 more is 14. Okay, so this is going to be subtracting here. We have a 7, we have a 1, and then we bring down the 9. Okay, so far we have 1, 5. Okay, now I think the 6 will work this time. So I'm going to go ahead and use the 6. 6 times 8 is 48. 6 times 2 is 12, plus 4 more is 16. And subtract that. 9 minus 8 is 1. 7 minus 6 is 1. 1 minus 1 is 0. Bring down this 6. I know I'm going to start getting sloppy here and getting into the other numbers, but it just happens sometimes. All right, so how many times does 28 go into 116? When we did 5, that ended up being just a little bit too high than 116, so I'm going to say 4 this time. 4 times 8 is 32. 4 times 2 is 8, plus 3 is 11. And then we have 6 minus 2, which is 4. 1 minus 1 is 0, 0. Okay, so now we bring down the 8. Okay, how many times does 28 go into 48? Just once, right? Just one time. So it'll be 28. 48 minus 28 is 20. And then we bring down a 0. 200. How many times does 28 go into 200? Probably about 7, right? Because 6 was pretty close. All right, so then, and that's not going to, let's see, 7 times 8 is 56, right? So we have 56. And so it's still not going to come out even, but we're a few decimals past, or a few numbers past the decimal. So we'll just stop there. Okay, so the answer for this one is going to be 156.417. Okay, that's going to be close enough. 156.417. All right, so Kate runs 4 miles in 24 minutes. So I made a little chart here with miles and minutes, and then I put 4 miles every 24 minutes. Well, we want to get to 30 minutes, and I realized I can't get directly from 24 to 30 without creating a decimal, right? So I just divided them both by 2, and then I got 2 miles will take 12 minutes. Well, I can't get directly from 12 to 30 either, so I just divided it again, and I got 1 mile every 6 minutes. Then I know that I can get from 6 to 30 by multiplying by 5. So then I would just take 1 times 5, and that would give me 5. So it says, how many miles can she run in 30 minutes? The answer is going to be 5 miles. Okay, and I basically found that by just scaling until I could get comfortably to 30 minutes. Now we are going to solve for y, which means we just need to get the y on this side of the equal sign all by itself. All right, well, that's pretty simple because we know we just need to find the opposite operation, or not find, but utilize the opposite operation of what's happening here. So if we have our y minus 11, you have a debt of 11. So how would you get out of debt? Well, you would add 11. And whatever you do to one side, you have to do it to the other side. Okay, so if you look at this, we have a negative 11 and a positive 11. So the only thing left on this side is y. 25 plus 11 is 36. So 36 equals y, or you can just rewrite it y equals 36. That's all you have to do to solve for y. All right, now we need to find the surface area, which means we have a triangle on the front here. We have a triangle in the back over here. We have this rectangle and another one on the other side, and then the base down here, right? So we have to find the area of each one of those. So what is 15 times 7? Well, 15 times 7 is 105. And I'm going to write that down 3 times. Why am I going to write it 3 times? Well, because 105 represents this side over here. It represents the side on the other over there, and then as well as the base. Okay, so it represents all of those. Okay, and then, so this is 105, 105, and 105. So then all we have to do at this point is find the triangle. Well, the triangle is 7 by 7, so 7 times 7 is 49, but it's a triangle, so we have to divide it by 2 to get the actual surface area, and that ends up being 24 and a half. 24.5. And I write that down twice because there's two triangles, one in the front and one in the back, right? So then we just add all of that up. So we have, let's see, 315. So we have 315 once we add the 105, 105, 105, plus, well, 24. Oops, I didn't have to put, let's see, what is that? 24.5, right? So we have 315 plus 24.5 and 24.5, which is 49, which equals 364. Okay, and so our answer is 364 centimeters squared because we're doing surface area. There we go. Find the mean absolute deviation. Mean absolute deviation, and that is the MAD, right? Mean absolute deviation of the data set. So here we added up 2, 3, 5, 7, and 9 and got 26. Divided 26 by 5 right over here and got the mean of 5.2. Then we brought that over here. We have 5.2 minus every number in the data set, the 2, the 3, the 5, the 7, and the 9. Okay, then we found the distance from that number, which is 11.2. We divided that by 5, and so here is our mean absolute deviation is 2.24. All right, so let's rewrite this non-statistical question as a statistical question. What did I score on my math test? Okay, so you took a math test. You got a score on it, and that's just going to be one possible answer. Okay, so that would not be statistical because there's no variance. There's no up or down. There's no, it's just one possible answer. But to make it statistical, you can ask all of the students, what score did you get on the test? Okay, so are you going to get a variety of answers on that? Yes, so that would be statistical because you can kind of measure what the different scores were for all the different students. So there we go. There's lots of different possibilities, but that's one very obvious one. Graph the ordered pair 5, 5 and its reflection over the y-axis. So we want to go positive 5, so that's to the right, and then up 5. That's 1, 2, 3, 4, 5 right there. All right, then we're going to reflect it over the y-axis. Here's the y-axis. How many places does it go? 1, 2, 3, 4, 5 places over. So 1, 2, 3, 4, 5 places over. That's where we put the reflection. Okay, so there we go. That's all we have to do for that one. Just go over 5 places and put that there. All right, that's all you got to do for that one. All right, compare the numbers with the greater than sign, the less than sign, and the equal to sign. Well, none of them look equal to me, so we're not going to use this sign at all. Okay, so we have a -6 and a 1. Well, that's easy. If there's a negative number and a positive number, the negative number is going to be smaller. And then we have a -4 and a -3, so not quite as easy. So you have to think about a number line. Which number is going to be further to the left on the number line? Well, it's -4. So the number that's further to the left is smaller. So -4 is less than -3. On a coordinate plane, a triangle is located at 3, 4, the ordered pair 3, 4, and a square is located at -4, 4. What is the distance between the square and the triangle? So I kind of drew a makeshift coordinate plane, and I plotted the triangle here at a +3 over 3, up 4, and then the square at -4, so we have to go left first and then up 4. So basically this is 3 from the line here, and this is 4 over from the line here, which means it's going to be 4 plus 3, which is 7. Okay, so the distance from the triangle to the square is 7. So to see it a little bit clearer, we put it on an actual coordinate plane. So you can see that it's 1, 2, 3, 4, 5, 6, 7 away. Okay, so, and again, you can just remember if one of the numbers are the same, you just kind of like combine the distances. So if you have a -4 and a +3, think of a number line and how far away are they from each other? Well, the +3 down to the -4 is going to be a distance of 7. So there we go, and that's all for this one.